In this question, we are told that the mass of a density bottle is 20 grams when empty, 70 grams when full of water, and 55 grams when full of a second liquid. We are required to calculate the density of the liquid. So this is such an empty density bottle. Let's say its mass is M1. Of course, we know that that one is 20 grams. The density bottle is filled up with water, and the total mass of the density bottle and the water, we can call this M2, and it's 70 grams. So from these two, we can get the mass of this water, the mass of the water inside the density bottle, which will be M2 minus M1. This one will be 70 minus 20, and that is 50 grams. This is the mass of the water inside the density bottle. This water here. It's just as simple as that. Next, the same density bottle is filled up with the liquid L, and the mass of the density bottle and the liquid, we can call it M3, and this is 55 grams. Again, we find that we can get the mass of the liquid inside the density bottle by subtracting M1 from M3. This will be 55 minus 20, and we get 35 grams. So we have the mass of the liquid inside the density bottle, and we know the mass of the water that was inside the same density bottle. Now, if we go back to the question, we find that we are required to calculate the density of this liquid. For us to be able to calculate the density of any substance, in this case, density of the liquid, we need to divide the mass of the liquid divided by the volume of the liquid. Of course, we know that the mass of the liquid is 35 grams from the calculation that we have just carried out. The challenge is to get the volume of the liquid, the volume of this liquid. Now, how can we get the volume of this liquid? We can do this by calculating the volume of the water inside the same density bottle. If we can be able to calculate the volume of the water inside the density bottle, we will have got the volume of the density bottle, which will be equal to the volume of the liquid. Again, let me repeat that because it is the main idea here. We realize that we are using the same density bottle throughout this experiment. So if we can be able to calculate the volume of the density bottle, the internal volume of the density bottle itself, we will be able to get the volume of the liquid, because remember, it is the volume of the liquid that we want. And because we know the density of water and we know the mass of the water, we can combine those two, density of the water and mass of the water, to get the volume of the water inside the density bottle. How do we do that? We just need to say volume is equals to mass over density. Do we know the mass of the water inside the density bottle? Yes, we do. It's 50 grams. It's 50 grams. Now, here we need to recall that the density of water is 1 gram per centimeters cubed. And this will give us 50 centimeters cubed. The volume of the water inside the density bottle is 50 centimeters cubed. That means that the volume of the density bottle itself, the internal volume of the density bottle itself, is also 50 centimeters cubed. And any liquid which is put in this same density bottle will have the same volume. That is why we end up saying that the volume of the water inside the density bottle is equal to the volume of the liquid. So over here, we quickly substitute 50 centimeters cubed, and this gives us 0.7 grams per centimeters cubed.